was a normal day. Sydney and Colin were sitting at their desks, working their typical 9-to-5 job, when something spectacular happened. They got a message. As the most qualified engineers in the world, Sydney and Colin were asked to help design a roller coaster for the new Seven Flags theme park.
Colin, wake up, we have to go.
Everything was going perfect until they got to the gate. It was locked. What do we do now?
Well, it looks like there's a note on that lock over there.
What does it say?
It says, find the solution of the matrix above using reduced row echelon form to get the code to the lock.
Reduced row echelon form? What's that?
I'll tell you, Colin.
Now, to begin with, we need to reduce the matrix given to us using reduced row echelon form. That means that each of the rows needs to have a leading one, and all the other factors of the matrix, except for the solution column, need to be zeros. We will start off by switching row 1 and row 2 to get the leading one in row 1. Next, we will begin a multi-step process in order to get values of 0 underneath our leading one. First, we will multiply row 1 by -2 and add that to row 2. Next, we will multiply row 1 by -3 and add that to row 3. And finally, we will multiply row 1 by -2 and add that to row 4. Performing all of these steps at once, while it can be tricky, saves a lot of time. Next, we will make the value in row 2, column 2, a leading one by multiplying row 2 by a -1. In yet another multi-step problem, we will find the zeros under our leading one in column 2. To do this, we will multiply row 2 by 3 and add that to row 3, while simultaneously adding row 2 to row 4. To get our leading one in row 3, we will multiply row 3 by -1 over 14. Next, we will put a 0 value under the leading one in column 3 by multiplying row 3 by -15 and adding that to row 4. Finally, to complete our diagonal of leading ones, we will multiply row 4 by -1/5. As you can now see, we have an upper triangular matrix. This means that all of the entries below the line of leading one diagonals are 0. Now, this is what is called row echelon form. Typically, we would solve row echelon form by using backwards substitution, but instead, we are using reduced row echelon form. In reduced row echelon form, we want all of the entries besides our solution column and our diagonal of leading ones to be 0. Sorry for the change of scenery, I had to change the paper real quick, but next we are moving on to yet another multi-step part of this process. First, we are going to multiply row 4 by -7 and add that to row 1, while multiplying row 4 by -10, adding that to row 2, and then finally adding row 4 to row 3. We are making the entries above the leading one in column 4 0. Next, we will make the entries above the leading one in row 3 0 by multiplying row 3 by 2 and adding it to row 1, and then multiplying row 3 by 7 and adding that to row 2. And there you have it. That's our solution. The solution column reads -1 0 1 2. Now, of course, we can't put a negative in our lock code, so our lock code will end up being 1 0 1 2. Look at that! Our lock opened. Now we can go into Seven Flags and build that roller coaster.
What do we need to do first?
Well, first, we need to use the gradient to find the path of steepest descent of the roller coaster. This way, we can build the roller coaster with the steepest hill to the bottom. The steeper the path, the faster you get to the bottom, and the more fun you have.
First, we need to find the path of steepest descent to find the most fun path of the roller coaster. Given the directions in the email we received earlier, we know to find the path of steepest descent of the roller coaster, given the equation W equals 2x squared minus y squared plus 8z. This equation represents the path of the roller coaster. Using the gradient will help us to find the direction of the path of steepest descent. This will be given to us in a vector value function. The formula of the gradient is given as follows. Delta W, or in most cases f, equals the partial derivative in terms of x, I, plus the partial derivative in terms of y, j, plus the partial derivative in terms of z, k. We will look at the equation again and find the x, y, and z component of the gradient. When we work this out, d dx equals 4x, d dy equals negative 2y, and d dz equals 8. We plug these numbers into the formula above and we have found the gradient. But not so fast. The gradient gives us the path of steepest ascent, but we need the path of steepest descent. In order to find the direction of steepest descent, we need to multiply the gradient by negative 1. Therefore, the path of steepest descent is delta W equals negative 4x I plus 2yj minus 8k.
Wow, that was a great explanation. But now that that's done, this message says we have to find the cost of the triple helix given to us in these blueprints. Let's take a closer look.